On our first mechanics lesson, we are going to see the difference between two concepts that are very close together, but have a tiny difference between them. I'm talking about distance, the concept of distance, and the concept of displacement. Let's imagine first a situation like this one over here. You have a race, for example. Here is a starting point, there is the finish line, and this is the path people have to go so they finish the race. The difference between these two concepts can be illustrated with this example. This would be the total distance traveled, and the displacement would be, however, just a straight line distance between the starting point and the finish line, the ending point. See here the difference, how they can be very, very, very different. What is then the distance and what is then the displacement? The distance is basically the total length traveled in a given trajectory. It's a scalar quantity. You already learned this in previous years. A scalar quantity is a quantity that is defined only by a magnitude and obviously a unit. So the trajectory here is important. If the trajectory would be something completely different, then the distance would also be different, the distance traveled until the finish line. However, the displacement is just a final position minus the initial position, and it is a vector. What is a position in the first place? The position is the location in relation to a referential. In this example over here, I decided that this would be the origin of the referential, meaning that this is the original position, the initial position, and this one over here, also a vector, is a final position. I mentioned vector because, as you already learned also in previous years, a vector is a quantity that is defined by a magnitude, just like the scalar, but also by a direction. And this is often illustrated in or represented in paper with arrows such as this, in which you have a starting position and the end point would be the end of the vector itself. Pay attention to the fact that the position where the referential is completely irrelevant. I could have put it over here, in a south pole, in a moon, doesn't matter. Whatever the initial position and the final position were in relation to that choice of referential, the difference between them would always be this orange vector over here, the displacement. See? There are situations, though, in which the distance and the displacement may be the same. This can only happen if you have something moving in a straight line and always in the same direction. In that case, the displacement and the distance would be in value the same. All right? But if the object starts going backwards, then, as we're going to see, it's not going to be the same anymore. This means that at the most, the displacement can be as big as the distance, but can never be bigger. Let's see a situation that encompasses everything that you'll need to know about displacement in a straight line. So consider the following situation. This is Joe. He's taking 20 seconds to go to the right, to go from A to B, and then 14 seconds to go to the left from B to C. He's always moving at the same pace, meaning that he's always moving at the same speed. We're going to talk about speed in the next lesson. So what is the total distance that he traveled? He traveled 100 meters over there. If you do the math, you will know that it is 100 meters. I wrote it down already. And then 70 meters over here. So 100 meters to the right, 70 meters to the left. So the total distance that he traveled, this was his path, his trajectory was 100 meters from A to B. Here I'm just focusing from A to B. So here the distance traveled was 100 meters. What about the displacement? The displacement from A to B, it's also 100 meters. See, here's the situation I was mentioning a little while ago, in which the distance and the displacement may have the same value. Joe only moved in a straight line in one direction. And what about from B to C? From B to C, the distance traveled was 70 meters. What about the displacement? If you look over here, it seems the same, but here you have a minus. What does this minus mean? The minus in any vector quantity means that the vector is pointing in the opposite direction of what you decided was the positive direction. And here we decided that the positive direction would be that way. So everything that points this way will have a negative value. This only is applicable to vectors. As you can see here, the distance, which is a scalar, is not affected by that. A distance is always positive. A vector may be positive or negative depending where it's pointing at. If we try to draw a distance time graph and a displacement time graph of these two, you have graphs that are different. Actually, from A to B, as you can see here, they are the same. They are both positive, so as time passes from 0 until 20 seconds, they both covered 100 meters, and for the distance, the direction doesn't really matter, but for the displacement, it is in a positive direction, so the graph would be similar to the distance. But as you can see here, from 20 to 34 seconds, here the distance continues increasing, and here the displacement goes down. Whatever the gradient, this is going to be important for what comes next, whatever the gradient is over here is going to be in magnitude the same, but with a negative value over there. So the distance time graph for Joe's motion would have a total distance of 170 meters, right? You add the 100 to the 70, but the total displacement, Joe's total displacement, would instead just be 30 meters, all right? The difference between the final position and the initial position, as seen here on the diagram, this over here would just be 30 meters. This would be Joe's displacement. This is his total distance traveled. One final note for you to understand that usually when you are doing graphs such as these, most of the times it's going to be a displacement time graph. If you see any line going down, it means that is a displacement time graph. If you see any line on the negative side of the y-axis, it is a displacement time graph. A distance time graph will always be positive and the line will never go down.